Once again, as you're working with geometric, you're talking about multiplying by the same rate each time, or dividing by the same rate. It can be positive, it can be negative. It's all good fun. It really isn't that bad. For example, like I said, the geometric ratio or sequence is nothing more than having a ratio of any term to the previous term is constant. That's a whole lot of mumbo jumbo for saying you're multiplying or dividing by the same thing each time. Okay? For example, I write in here look to divide. Well, I'll just use the one I have here. If I'm going geometric sequences series 11 3. If I'm looking at this first grouping, I have 1, 2, 6, 24, 120. Yes, ma'am. You don't have to write it all out. I'm just saying just have to look this up. I'm going to show you right now. That's why we're going. That's why I don't go spend a lot of time on the actual vocabulary. I like to kind of talk a little bit about it and then show you right away, because I know that once you guys see it in terms of numerical versions of stuff, it clicks quicker. I hope. So, like I said, the geometric sequence is the ratio of any term in the previous term, one after another, is constant. It's the same value each time. And the way that we do this is we use division to check it. This is a very, very easy thing to do to see if something is geometric. Okay? You're looking at these ratios. Remember, a ratio is nothing more than two things being compared together by division. That's all it is. All right? So when I'm looking at it as numerical, don't get over with you, puppy. It's okay. When I look at this first example of 1, 2, 6, 24, 120, what I'm checking to see here is each consecutive term is 2 divided by 1 the same as 6 divided by 2, the same as 24 divided by 6, the same as 120 divided by 24. Are these all the same? No. So is it geometric? No.
All right.
Hi.
Hi, Miss Murph. What are you looking for? I'm looking for Kendall. Hampton.
She is, I think, probably with the Taiwanese. All right. Now take a look at the other one. Do you guys see how I'm going from second to first, third to second? I'm working that way. It's kind of that's always the easiest way to set these things up. So if I look at the other one here, if I go 27 over 81, is that the same as 9 over 27? Is that the same as 3 over? Yeah, you see, you're all going to get what? 1/3. The common ratio in this case is 1/3. You're multiplying everything by 1/3 each time. Could you say you're dividing by 3? Yeah, you can do that too. I will suggest this to you guys. If you write it out as a fraction, it's always going to be easier than trying to write out division stuff, okay? So in that case there, the geometric sequence would be first term is 81, and now instead of being a difference, we have a common rate. What do you think you use for rate? R. R. Sorry.
Is it okay if I add more than one R?
If you'd like to. All right. So your common ratio in this case would be 1/3. Each number is generated by multiplying the previous one by 1/3. Not so scary? So here's how we set up to write out what's called the nth rule for geometric. I just wrote up the same example we just had a second ago with the 81, 27, 9, 3, 1. That's the same example we just talked about. So your generic rule for geometric your nth term rule for the geometric sequence is a sub n will be your first term times the rate to the n minus 1. Yeah. And you're not combining like terms or anything here. it's very, very easy to write this out. So in this example that we just did, what was your first term? 81, good. So your first term is 81. We already discussed what our rate was. It was 1/3. Now in order to write out your nth rule, all we do is substitute in. A sub n is first term times the rate to the n minus 1. That's it. Questions? No, we just started. I know. The first one's always easy. It's then all of a sudden you kind of go off. All right. So here, let's take it the next step. We'll start with the geometric sequence. It's telling you who it is of -8, -12, -18, -27. We're going to write out the nth rule, and then we're going to figure out what the 8th term is within the sequence. Yes, ma'am.
You're supposed to multiply that with the 81 and 1/3 and the last one.
You just leave it exactly like that. That is your rule for the nth term. Same question? Yes. Sorry if I didn't really explain that here. This is the rule. You leave it at that. Because when you're trying to figure out what term it is in the sequence, if I substitute in 8, I'd have to substitute in 8 here, then order of operations would tell me to take care of my exponents first, then I'd multiply. So I couldn't combine those. Does that make sense? All right. So back to this one. If I'm starting out with -8, -12, -18, -27, and I need to write out the nth rule, we got to figure out our common ratio. Well, it's nice because it tells you it is geometric, so all you have to do is divide it out once. What is that? 3 halves? There's your rate. Do you guys know how to simplify fractions in the 84s?
The what?
Take out your calculator. Let me show you how to simplify the fraction. Well, it's a good thing I'm going to show you again right now. In order to work with the fractions in the 84, what you're going to press right off the bat is alpha y equals. Okay? Then press enter. And I'm going to type in that -12 over -8, and I press enter.
Whoa.
Oh, so I have to do it once.
I have to do it once.
Ah.
It's just like.
You just have to find the button, that's all.
Hey, mine did
What?
Well, then I can help.
I just reset it for you. It might have an old setting in it, that's all. I just reset it for you. It won't be a big deal. It should be fine. Okay, is everybody okay with that? Very easy to work with. So our common rate is 3 halves. So our nth rule is your first term, r to the n minus 1. We agree? Not that bad. Now to figure out what the 8th term is, you just substitute in 8 into n. Now, again, you could type this directly in your calculator like that. I'll show you. If you type it exactly the way that it's written with the parentheses, it's going to be fine. -8, parentheses, alpha y equals 3 over 2. Close the parentheses. Remember how to go to the exponent? Caret. Caret's right above the division symbol. Could you figure out what 8 minus 1 is in your head?
7. No.
What?
Yeah.
Yeah.
Is that the answer?
We met.
Is that simple?
Yeah.
that a new quote? No,
But how do you write that as a
You have
quote
to
with,
put in
with,
like
the, with
asterisks, British accent.
British accent? I think it might be. That's good. I like that. I like that one. All right. But yeah, it's basically that easy. Okay.
Yeah.
So go for this one. Try this one. All right. So your nth rule. Well, the problem here is you need to use a negative symbol, not the minus symbol. There's your problem. Ladies and gentlemen, real fast, just so you remind yourselves, there are two symbols that look like negatives. One of them is a negative, the other one is not.
I've done that more.
One of these things is not like the other. One of these things is different. Negative, minus.
I've done that more.
So you got what, negative 8 something?
8192.
8192? Very, very simple, right? Of course it does. Don't worry about graphing. We're not going to worry about graphing. Graphing geometric sequences, it's graphing exponents. It's something we'll do later. But like I said, we're kind of doing everything out of order right now. So here we go. This is where things start to get a little bit different. Remember we were talking about this yesterday with arithmetic. You know how you had like 3 or 4 different variables within the generic rule. Now when you're talking geometric, you have your nth term, your first term, your r. So there's really 3 of them there. So we can kind of mix things together to solve for the other depending upon what you're looking for. Now, if I want to write the rule for the nth term of the geometric sequence, and I know that the third term equals 5 and the rate is 2. If the third term is 5, what's the value of n? 3.
Oh, duh.
Okay, it mirrors the same thing we were talking about yesterday. When you have the nth, a sub n, a sub 4, that means n is 4, and so on. So what I'm doing here is, I need to write out the rule for the nth term. So we start out with, well, the a of the nth term, in this case, is 5, equals my first term, because I don't know it, times the rate of 2 to the n minus 1. Are you okay with that? So what's 3 minus, wait, what? What's 3 minus 1? 2, okay. So you wind up, when you simplify this out, you get 5 equals the first term times 2 squared, which is, how do you undo multiply by 4? Yep, the first term is 5/4. Okay, does that make sense?
Yes.
Ms. Hayes? What I did here was,
Yeah, I'm confused.
this is a multiply times 4, okay? How do you undo multiplying by 4? Yeah.
Is that just like power 3 over 1 minus 7, or is that negative?
This is an
Oh, it's
arrow,
an arrow.
arrow, sorry.
Okay.
Wait, how'd you get? Oh, n is
N-
under a.
This is my nth value here, the third term, a sub 3, so the third term is 5, so the nth term in this case is 5. We're talking about the third term being 5. That's what we're doing. Just like yesterday, you had to do like some sort of a system sometimes to figure out that first term. This case, it's a little bit different. All right? Substitute what you know, just kind of work your way out of it. So that gives me my first term. What am I done? No, because it asks you to write what?
That's too easy.
It just asks you to write out the whole rule. Now you have your first term. Did you already know your rate?
Yeah.
So now, knowing that the rate, your nth rule will be your first term, rate n minus 1, you put them all together, you get 5/4 times 2 to the n minus 1 is your rule. So we just had to solve for the first term in this case. All right? exciting.
I like it.
Okay? Now where it gets kind of fun.
Will we be graphing?
No, we won't graph these. We won't graph these.
Yes.
Well, like I said, we'll graph later. Trust me, there's a lot of graphing in this book. No, I'll give you graph paper when you need it. And like I think I've said this before, when we get to graphing, I don't really want you to use graph paper because I want you to scale it and I want you to show representation. When we get to graphing, I'll explain expectation. It's very, very straightforward. So now we have two terms in a sequence. We need to find the rule.
Oh, I see.
Now remember yesterday when you had two terms in the arithmetic sequence, what did we do twice?
System.
We did systems, right? So we wrote down the generic rule twice, correct?
Yeah.
What do you think I'm gonna do now?
Do that twice.
Do that twice, okay? So I'm gonna write out the generic rule for the nth term twice. Okay? Now that I know that one of the terms, the second term, is 45, in this case, what is my value of n? 2. Everybody okay with that?
Yeah.
All right. So that means the n value here is 2. I don't know the rate, which is fine. So I'm going to substitute. Hey, how are you? You guys just want to have a seat. I know if you want to grab an extra chair to sit next to
Okay, I'll sit.
that's fine. No problem. So what I'm going to do here is I'm going to write out, I'm going to substitute in these values into the generic equation and leave it as that. So the nth term here is 45. That has to equal the first term times the rate to the 2 minus 1. Is everybody okay with that?
Yeah.
What can I simplify here?
2 minus 1 is 1.
You almost said 2.
You know.
I would have made the board.
Yeah, I should
Okay.
have said 1.
Is that okay to leave it like that for right now?
Yes.
All right. I'm going to go to the other set and do the same basic scenario. When I go to the other one, I have the fifth term now, so my a to the fifth term is negative 12, 15. So that means n is how much in this case?
5.
Good. N is 5. I'm going to substitute that into the generic formula, knowing that the fifth term is negative 12, 15. That has to equal my first term, a sub 1, times my rate to the 5 minus 1.
4.
Or 4.
Very good. Just going to rewrite that. Do I have two equations?
Yeah.
Yes.
Two variables.
Yes.
In this example, I cannot use elimination, can I?
No.
No. Substitution.
1
I have to use substitution. So what I want to do here is I'm going to set the equation on the left equal to a sub 1. How do I do that? Good. Everybody okay with that? You guys ever heard of a term called literal equations?
No.
No.
Literal equations. You guys have all done this. Distance equals rate times time. How do you solve for time? So distance divided by rate is time. Agreed?
Yes.
How do I solve for rate?
Time.
So the distance divided by time is your rate. What you're doing here is you're using what's called a literal equation. You're solving for bits and pieces by just moving them around. It's okay. You're using, just like it would be numerically, you're using the properties of multiplication and division to move things back and forth. It's fine. I do the same thing here by dividing by r. So I know that the first term is 45 divided by r. Are we okay with that?
Yes.
All right. I'm going to take that and substitute into the other equation. Ah, sneaky, sneaky. Now, move this up a little bit. I get negative 1215 is now 45 over r times r to the fourth. All right, let's see what you remember about exponents.
They go first.
What is r to the fourth divided by r? Very good. Does everybody remember that? Okay.
I didn't even hear.
I think it's weird that.
When you're dealing with exponents and division, when you have same variable, different exponents, what you're doing here is you're playing the game of war. Everybody ever played that?
Yes. Yes.
Yeah.
Never played war.
All right.
That's the best game.
In this case here, which one is bigger, 4 or 1?
4.
Who wins?
4.
So what's 4 minus 1?
3.
So what's r to the fourth divided by r?
R.
r cubed.
So it's 45
What happens here is you're just subtracting exponents. Okay? You are playing the game of war. Now it's a two-step equation. Very good. Divide both sides by 45.
Oh, wait, I got it.
And you should get negative 27.
Yeah.
Square.
Cube. Cube root. So now we have to know how to undo third power. In order to undo cubing, we have to take that root. In your calculator, there's a button for this. In this case here, we're talking about the cube root. It has that little 3 before the square root. Okay? Math. Number 4.
Oh, yeah.
So now we're going to take the cube root of negative 27, and there's my answer.
Negative 3.
So what's your rate?
Negative 3.
There you go.
I think I knew that.
All right. Well,
Wait, how are you supposed to do this?
so now we have to write a rule.
You hit that, and then click on option number 4. Okay? Okay? Math number 4. We okay on that? What are 3 numbers that are exact same number that multiply together to get negative 7, or negative 27? Negative 3 times negative 3 times negative 3.
No, I know. What, like,
What did we solve for? We solved for the rate of the geometric sequence.
What are we supposed to be solving?
No, we're not done yet.
I forgot what we were supposed
We have to write the
solve.
rule.
We gotta write the
I don't
rule.
know what.
But this is the easy part, because you now know, in order to write the rule here, the rule is a sub 1 r to the n minus 1. You know what the rate is. We just have to figure out what the first term is by looking on the sheet, okay? No sheet. Well, how am I going to do it? Sorry.
I know, it's negative 15. It's negative 15.
It's negative 15.
All right,
What are you gonna ask?
I think I did. Never mind.
Does everybody see why I have to go back? Once I get this, I have to substitute back here. That gives me my first term. Okay? In these cases, again, the arithmetic that we're doing is not that difficult. There's just a couple extra steps. So 45.
Hey, it's negative 15.
We said that like 5 times. So probably
That's how you set this stuff up. Okay?
No, we don't have to.
Do this one, please.
We said a red rule, please.
I want you to write out the nth rule. Same process. You're going to, since you have 2 different values, you're going to write out the nth rule generic form twice. I'd say 99% of the time when you do that, you want to get the first term solved by itself, and then you substitute that in the other way around. Okay?
Oh, okay. Wait, what do we have to do?
You're going to write the nth rule here.
Oh, okay. One second, I got
We're running a little short here. I'm going to start kind of walking through this here.
No, I know, I'm done.
In order to change something that is not just a regular old boring cube root, let's say if you had to take the 5th root or the 6th root or something like that, what you're doing is you're taking the nth root. In order to do that on that calculator, I hear people starting to ask that. If you hit math, see number 5 where it says x roots? That's how you change the value in front of the radical. The index, if you will. All right? That's how you change it. Did everybody get to this point here? Give me a second, please, because I know we don't have much time.
Yes.
So you've got -4 divided by your rate becomes the first term. Does everybody agree? Does everybody also have on the other side, -1024 is your first term times r to the 5th power? Okay. So I'm going to take this value, and I'm going to substitute in here for the first term, which gives me -1024 is -4 over r times r to the 5th. Who wins that battle, r to the 5th or r to the 1st?
R to the
What's
5th.
5 minus 1? 4. It's a golf reference.
4.
Wait, why?
I get it. Maggie, did you get that?
I did get it.
I got
did it
it.
at
We
least.
actually did
In this case here, yes ma'am.
What do I do with the other one?
If the other one was what?
Then you just said -4.
That's why I put this quick example up here in case you had forgotten. If it's x to the 5th over x to the 8th, who wins? So it stays in the denominator. You play a game of war. Whoever's bigger, that's where it stays. Yes, sir.
Quick question, on the test on Tuesday, will we?
It won't be Tuesday. I know that for a fact. It's not going to be Tuesday. We're a little bit slower than I
Alright, so
anticipated.
are we gonna have like these equations that we've been having
Oh no, you got to know these, man.
oh,
I haven't. To be honest with you, I haven't quite decided on that yet. I really haven't decided. I'm right now. I'm 60-40. You need to know that.
Oh, man, it's just.
I think that 40 should win though, because first test, and I'll just cut them slide.
Yeah, you know, but here's a good old adage. You can wish in one hand and the other, see what fills up first.
Right.
What's -1024 divided by 4? -4.
Equals on to the 4th.
256?
What was the other one?
Use your imagination. How do I take the 4th root of 256? What did you guys get?
4.
So my rate is,
Sorry, how do you
in your calculator, if you hit math, number 5, it comes up with this x root, but sometimes it comes up and says answer. Just back it over it and overwrite it with a 4. And then we'll take, okay? And now it's very easy to get your first term. Do you agree? Okay? Yeah, because we don't have time for the other one. Just kind of
Is
open
the
it.
other one with the
No.
I got to.
The other one we need to do, I have to teach you guys something new. So we'll probably, so here's what we'll do. I'm going to stop it here. We'll do the series of geometric stuff on Monday. But what I'm also going to do, because a lot of you guys keep asking the questions about infinite series, I'll also do a little bit of that on Monday as well. How you can add those. How you get
What was the final equation?
Final equation was -1 times 4 to the n minus 1, if I'm not mistaken.
Yeah,
I hope.
you're right. You're right.
Of course. Let's work on these. Yeah. What I'd like you guys to do, this is section 11.3. I'm going to give you the odds on these so you can check your work, all right? I'll give you the odds on these so you can check your work.
Do the odds in the deck, like
Yeah.
show how to do it, or is it
No,
just the answers?
it's just the answers. All right. If you wind up, and I told everybody else this, if you guys ever come to the point where you needed to check how something worked, if you were figuring out how something was working, the big book of answers is in that wall cabinet. So you can always come on in, stop in real quick, take a look at it, and see how if you're right or not. Okay? I don't hide it from you guys. You guys are more than welcome to look at it whenever you want. Okay?